Now let's work on Fall 2010 Math 227 Test 2, number 1, part C and D. In the other video we already did the A and B, part C and D. Part C, find the probability that of 6 voters, more than 4 voters vote for McWhitman. Let's define a new random variable. Even though part B and part C are both for McWhitman, but the number of trials now are different. Earlier it was 30 for part B. Part C now you have only 6 voters. Okay, so that should constitute a new random variable. Let x3 be the number of votes for McWhitman. This x3 will then be binomially distributed with number of trials 6, and the probability of each success is 0.39. Now the question is, find the probability that the number of votes for McWhitman will be more than 4. Now to compute this is actually, you can do it this way. This is a probability that x3 equals to 5. The number of votes for McWhitman is 5, plus the probability that the number of votes for McWhitman is 6. Okay, now this is equals to, then I will use a calculator. Let me show you how to use a calculator here. Will this be a good view? Okay, I will go to distribution, binomial PDF. Okay, and then the number of trial is 6, probability of success is 0.39, and I want to have 5 successes. The probability is 0.03302 plus, let's see what happens if the probability of the number of successes is 6. That's pretty much the same entry, right? So I go second and entry, and then I go back. Let me change the 5, now becomes 6. That will be 0.00352, which if I add these with the previous numbers, it will be 0.03654. Okay, now that's the probability that the number of votes for McWhitman will be greater than 4. Actually, we can do it another way, but this one makes you need to think a little bit. If you can get this, that will be great. The probability that number of votes for McWhitman is greater than 4 is the same to 1 minus the probability that the votes for McWhitman is less than or equals to 4, right? Strictly greater than 4, the complement of that statement is less than or equal to. Now, why I want to do it this way? Because from here we can use the binom PDF, CDF, binom CDF. Okay, let me show you. If I use binom CDF, the real fraction is not good. Okay, this one is good. And the number of trials is 6, and the probability of each success is 0.39, and you want the probability cumulative up to 4. That is 0.9635459, which I round to 6. And if I subtract this from 1, that will be 0.03654, which is the same with that one. Okay, now let's do the last question, part D. Find the probability that any of those 6 voters are or is undecided. The number of undecided, the percentage of undecided is 12. Now let x4 be the number of undecided voters. Then that x4 will be binomially distributed. Number of trials is 6, and the probability of each success means the probability of a voter is undecided is 12%. Now, what is the probability that any of these 6 voters is undecided? So I hope you remember that this is basically asking you greater than 1, right? Greater or equals to 1. Now, somewhere in the past, when we need to compute probability of something at least 1, I hope we remember that this is 1 minus the probability of that random variable to be 0. Okay? The complement that any of those 6 voters is or are undecided, the complement of that statement is none of those 6 voters is undecided. Now, then from here I use 1 minus, going back to my calculator, that's binom PDF, number of trials 6, but this time the probability of each success is 0.12, and I need 0 successes. That is 0.46440. Subtract that from 1, it will be 0.53560. Okay, that's for part D.